Recording right now. Okay, so in this lesson, I said there were a couple of different ways we're going to learn how to solve it algebraically. This one deals with solving it by substitution. Okay, substituting means we're going to find something that we can substitute from one equation into the other equation, because we're going to have two equations working together. So find the equation. Today, what we're going to do is we're going to look for the equation that is solved for either x or y. So we're going to look at the two equations. We're going to say, are either of them solved for either x or for y? It does not matter which variable they are solved for. And then we're just going to circle the expression that that is equal to. Okay, and the reason I have you circle it is because then you're going to see this is what you're actually going to do. You're going to substitute what is circled you're going to substitute that expression into the other equation. And so whatever you're taking from one equation has to be substituted into the other equation for that variable, and then you're going to solve the equation. And then after we get, so whether it was x that we end up solving for or y we end up solving for, it doesn't matter which one we solve for first. Whichever one we get, we substitute that solution into the equation that has the variable alone. And then we put our solutions for x and y into an ordered pair, because we know that on a graph, that would be the point of intersection, just like we've been doing when we were solving by graphing. So today, these are the steps you'll follow. Number one, you're going to go look at those two equations. You're going to look for one of them to be solved for x or for y. You're going to circle the expression that it is solved for. And then you're going to substitute that into the other equation and first you're going to find an x or a y solution. Then you'll go and find the other one and set your answer up as an ordered pair. Okay, so let's look at this system of equations we have here. Are either of the equations solved for either x or for y? Okay, the first one or the second one? First one, and it's solved for what? Y. It is solved for y. Y is by itself. We're going to take that expression that it says y is equal to, negative x plus 5. You remember that's what equal means. Negative x plus 5 is the same as y. So in the other equation, where there's a y, we're going to substitute that expression in. Because we're saying this is what y is equal to. Even though it's an algebraic expression instead of a number, right now this is what y is equal to. So let's substitute that into the other equation, because then what should happen? What do you think should happen when we substitute negative x plus 5 in for y in the other equation? We shouldn't have any y's anymore. They should be temporarily gone, and we should be solving for x. So we're going to take that other equation, and let's change that to add the opposite. So x plus a negative 4. And we're going to substitute in for that y, that circled expression. And so the other equation should remain the same, except for that y getting replaced by what it is equal to in the other equation. And now we know what to do. What would be our first move now? Distributive property. We got to get this simplified. So we're going to take that negative 4 and we're going to distribute it. So we have x plus, what's negative 4 times negative x? 4x. Plus, what's negative 4 times 5? 20. Negative 20. Okay. We're not really solving yet. Right now we're just simplifying this. Can we do any more simplifying? Yeah, we can do what? Add those x's together, okay? So now combine the x's, we end up with 5x plus negative 20. Can we do any other simplifying? No. Now we're ready to solve. Go ahead and solve this equation for x. You get 6? Yeah, okay. So we now know one of the solutions, one of the parts of our ordered pair. We now know that at that point of intersection of these two lines on a graph, we would be at x equals 6. Now we just need to know what?
What y equals.
What y equals, okay? So it does not matter which equation you use to put your x value into, because both equations have the x's, both of them have the y's. We know what x is, we need y. But which equation does it make more sense to put it into, the first one or the second one? The first one, because that equation is already, it says y equals, and that's what we want. So we're going to use the y equals, like I said up above, substitute that value you find back into the equation that is solved for the single variable. So we're going to substitute in that negative sign is not part of the x, it's in front of the x. We're going to put our 6 in for the x. And what does y equal? -1. So ordered pair, what? What's the solution?
6, -1.
Ordered pair, 6, -1. The x value is 6, the y value is -1. There's our solution. Or in other words, what would happen on a graph? That's where these two lines would intersect. If we solved it by graphing, we'd get the same answer. Well, we should get the same answer. Okay. So any questions? Okay. To go to the back side in that next problem that we have to do together here, I want you to kind of get yourself set up to get started on this. Don't go too far. Let's just, you're working on homework right now, let's say, and you're deciding, how am I going to do this? Second equation is solved for x, isn't it? Remember, does it matter which one? No, we don't care. So it's saying x is the same as 3y minus 2. So we have to put it into our other equation, but before we do that, we're just going to write that other equation down, and we're going to make it more user-friendly. How do you think we can make that other equation more user-friendly? Add the opposite. That's one way. And I'm thinking the other thing I might even want to do is stick some 1s in there. That might even help. Because there's invisible, it's 1s there, they're being multiplied by 1, aren't they? Which end up being a -1. Now remember, we're substituting in for the x. We're substituting in for the x, so -1, 3y, let's change that also to add the opposite, 3y plus a -2. Trust me, this is a really good time to start changing things to add the opposite, if you haven't been, especially if you haven't been really successful. Okay, so we now, I can't put an equal sign there yet. We have done the 1, we put in this for the x, we still have all the rest of that equation to write down. Last part of my 10 here. Okay, so we have plus a -1y equals 10. So for the time being, the x's are gone, we only have to deal with the y's, we should be able to do this. So now we say, okay, I got distributive property to do first of all to simplify this. Do we have some more simplifying we can do? Okay, what can we do now?
equals
Combine the y's. So what do we have?
negative 4y plus 2 equals 10.
Negative 4y plus 2 equals 10. We brought the y's together. And now we're ready to solve it. So go ahead and get your y value. What is y equal to? Anybody agree with me? Need to challenge me? Maybe I did it wrong. Anybody get negative 2 for y? Okay, a few of us did. Okay. Think we can go with it? Okay, and then we're going to do what now?
Solve for x.
Now we got to solve for x. So if you want to make that yourself that little note, we're now needing to solve for x because we already have our y. Well, which equation do you want to use to solve for x? X equals the one that has x all by itself already. So we solved for y. We know that y is negative 2. We can also make this add the opposite. So x equals negative 6 plus negative 2. X equals negative 8. So what's our ordered pair solution?
Negative 8, negative 2.
Negative 8 comes first in the ordered pair. Negative 2 comes second. Here is our solution. These two lines would intersect on the graph. And we're compared negative 8, negative 2. Okay, so far, for those of you who actually legitimately did try or have SP3R in less than 5.2, does this help? Is it making more sense now? Okay. How many of you like solving it algebraically better than graphing? Yeah. Some of us graphing is not our thing, we're gone. But we don't have the visual. The reason we learned the graphing way first is now, can we visualize that we got two lines on a graph and they're intersecting at that ordered pair? Okay, and we're going to do an application problem. Kind of looks like that one we tried one day with guess and check. The sum of two numbers is 75. So there's a whole bunch of numbers that add up to 75. How many pairs of numbers do you think we could find that add up to 75? Infinite. Doesn't say they have to be integers, does it? No. We could be adding a positive and a negative. We could be adding two positives. We could be adding fractions, decimals. We could have all kinds of things. Well, the good news is they're going to give us some more information. The second number is 3 less than twice the first. That almost sounds like, well, she's a cousin to my uncle, who's a brother to her grandma. You know, have you ever heard something like that? And you're like, huh? Well, the second number is 3 less than twice the first. Huh? What are the two numbers? What do you think we could do? We have two numbers to find. Does it say they're both the same? No. If they were both the same, we could have been done after they told us that the sum of the numbers is 75. We could have split it in half and said, okay, here's what it is. Well then, maybe we should call one of them X, and we'll call it the first number. Whenever you do these problems, I want you to do this. Take the time to write this out, because this is helpful. Trust me on it. Just do it. I let you off the hook today. I stamped some papers I shouldn't have. So now you owe me. Y is second number. And we're going to set up a system of equations with the information that they gave us. So Anybody think they can offer up a one equation that would get us going here? Hey, Jacob?
75 is equal to x plus y.
75, the sum is equal to x plus y. Okay, that works. The sum of the numbers is 75. Okay, anybody want to offer up the second one? Abby?
Y equals 2x minus 3.
The second number is 3 less than twice the first. Good job, Abby. Y equals 2x minus 3. The second number, y, is equals 3 less than means 3 better be getting subtracted from something. Twice the first, well, the first number is x, so 2 times x. Okay, now we'll use substitution to solve. So now we'll say, okay, second equation is solve for y. So I'm going to take that expression, put it into the first equation for its y. So we're going to write down that first equation. And we're going to substitute in for the y, 2x subtract 3. Now, notice I didn't put parentheses this time. Why not?
It's not being distributed.
Because there's nothing to multiply by. And the reason there's not anything to multiply by is because there was nothing in front of that y, and because it was addition. Had it been subtraction, that would have been a different story. Okay? So that's why I'm going to say change subtraction to add the opposite so that you can see, oh, wait a minute, I really have a negative 1 to multiply by. Here we would have a positive 1. Would a positive 1 change anything? Multiplied by a positive 1? No. So now we can simplify this. What does it simplify to?
3x minus 3.
3x, take away 3. Okay, go ahead and solve and find both of these numbers. You know what to do. Well, I use that eraser so bad here. Make you smaller. This one we don't have to write as an order for solution. They would actually intersect at this point on the graph. And what would be the order pair?
26.
26, 49. Now, we could have just as easily assigned the first number y and the second number x, and then it would have been reversed. So it does not really matter in this situation. We just needed to find the two numbers that meet the conditions. So let's do a mental math check here and see, make sure it meets the two conditions. I got 49 and 26. Do you guys agree with me?
Yes.
Okay, do 49 and 26 add up to 75?
Yes.
Yes, they do. Okay. The second number, what's our second number? 49. The second number, is it 3 less than twice the first? Well, what's twice the first? 52. And 52 take away 3, is that 49?
Yes.
Yes. Looks like we did what we should have done. So the two numbers are, so now we're ready for our sentence. You guys seem to think you're done, but I bet you're not. It's a application problem where you write a sentence. The two numbers are 26 and 49. Okay, any questions on that? Okay, well, claim to be done then.